All right, so today we're going to talk about section 1B, displaying and describing categorical data. And so we're going to start off with our first type of categorical display, and it's important to note that every graph we talk about today is specifically for categorical variables. So we talked last week about the difference between categorical and quantitative, so we need to make sure that we can differentiate between the two. We have one set of graphs that work categorically, we have another set of graphs that work quantitatively, and so we have to make sure that we're matching the appropriate graph with the type of variable that we're working with. And so bar graphs would be our first type of graphical display involving categorical data. So it shows a category as a bar. The heights of the bars shows the category frequencies, the counts, or you can create a relative frequency bar graph using the percentages from your relative frequency table. And so basically all this is just a visual representation of our frequency table. So last week we talked about the preferred method of communication between friends. We looked at a frequency table where they counted how many individuals preferred each method, and then we had a relative frequency table. And so as we look at this, it's important to note we're talking relative frequencies, which means we're working with these percentages. And so that's what we're going to take is those numbers from the frequency table, and we're going to create a visual, a graphical display of those numbers. And so a couple of things to note in the graph here. The x-axis we label with our variable. In this case, it's preferred method of communication. We also then have each of the individual categories listed out, evenly spaced along that x-axis. And then as far as completing the graph or creating the bars that we need here, we have to look at that y-axis, which is showing us the percentage of students. It's important to have that label so we know we're working with percentages or with counts, whatever the case may be. And so as we look at that y-axis there, we notice that we start at 0. That's going to be a point we make on this next slide here. And then we went in even increments of 10 all the way to 60 to make sure that we can account for the largest percentage in our data set. And so all that happened here is that we went ahead and took the percentage from the frequency table and created a bar with that height on our graph. So when we had the in-person communication, that was 24%. So we went to 24% on our y-axis, and we drew a bar at that height and then created said bar for that particular category. Okay, so it looks something like this. And then we did the same thing for the internet chat or the instant messaging. We did the same thing for phone calls, social media, text messaging, and so on. So we just go category by category. We measure the height of the bar based on the percentages, or if we're doing a frequency table, the counts, and then just creating the display from there. And then what we're able to do is look at that bar graph, and we can then visually see text messaging was the most common preferred method versus phone call was the least common, and so on. So now we can actually see the differences in the different categories and be able to analyze it based on the graph. As far as creating bar graphs, okay, I'm not going to go through this whole thing. If you need to pause the video at this time to get everything copied down, is perfectly fine. But basically we draw and label the axes, make sure we have the x-axis is that variable with the different categories evenly spaced. The y-axis is your frequencies or your relative frequencies, so your counts or your percentages. And then really the most important thing on this slide here is when we scale our axes, the x-axis is not a big deal, just evenly space out the categories, but the vertical axis must start at 0. So that's a really important factor or really important aspect of these bar graphs is that y-axis must start at 0. And then the other piece of that, we need to have equal intervals or even increments starting at 0 up until our maximum value along the number line. So making sure we have all that stuff evenly spread out and even increments starting at 0. And then we talked about drawing the bars above each category and going from there. So you can get the rest of that copied kind of on your own time here. The next type of graphical display that we're going to discuss is pie charts. This is another thing you probably have seen before. You've worked with these, so it's not a new topic. The big thing I want to talk about with pie charts is just understanding that we have the parts of the whole. Like if I'm going to create a pie chart, it has to be something where I'm gathering data from one group of individuals, so it cannot be multiple groups. I have all of the categories accounted for, all of my relative frequencies or my percentages add up to 100%. So if I'm analyzing parts of a whole, we would be allowed to create a pie chart from the given information. Now, we're not going to be creating pie charts in class or on a quiz or a test, so the process for creating a pie chart is not going to be a big issue, but being able to determine if we need a pie chart or can make a pie chart, or just looking at it and kind of picking out pieces of information that we need. And so on the left side here, you see what a pie chart would look like. We have the different wedges represent the magnitude of that particular category. We also have the labels in the picture with the different percentages for each wedge, as well as what the category stated for that particular one. And so that's what we would be looking at for a regular pie chart. Now, one of the things as we talk about these graphical displays is making sure we talk about accurately reflecting the data by not creating misleading graphs. So on the pie chart on the right side here, okay, it's a pie chart where we have the parts of the whole. We created the entire thing. A lot of it looks good in terms of it has the values and the labels. It has the percentages listed in each of the different wedges and so on. But the problem with this type of graphical display is that in this case, because of the 3D aspect, because they've tried to make it a little bit nicer looking and things like that, they created this three-dimensional aspect to it. It misrepresents the data by looking at this wedge in red versus the wedge in yellow. So as I'm looking at this, because of the way it's set up, because of that three-dimensional aspect, that red wedge looks like it's bigger than the yellow wedge when the yellow wedge has a higher percentage. So when we create these graphs, we have to make sure that everything accurately reflects the numbers from the tables. And so in this case, we're not accurately representing the information, as we have the 28% looking to be larger than the 30%, which doesn't work. And so we got to be really careful when we create these displays to make sure we're not misleading others, as well as when we are looking at other people's information, making sure they're not misleading us, whether intentional or not. So did they accurately reflect the information, or is something misleading us, trying to drive us one way versus another? So that's our pie charts. Big thing again, parts of the whole, making sure we have all the individuals, all the categories, everything adds up to 100% for my one single group. The last type of display we're going to discuss today are side-by-side bar graphs. And so basically it's just bar graphs where we're using comparisons. We're trying to compare one group to another, or we're trying to compare three groups together, whatever the case may be. So we have multiple groups, we have information that we want to compare. So side-by-side bar graphs are kind of the easiest way to go about that. So in our example, we're looking at the difference between tweens and teens and how much time they spend on digital devices each day. So they went ahead and created a sample or collected a sample of 1,300 US teens and tweens, 8 to 18 years old, to figure out what the difference between the groups is. So we're going to create side-by-side bar graphs to summarize the data that they recorded from that sample of 1,300 kids. And so one way to create a side-by-side bar graph, we're going to talk about two different formats. One is to simply separate the two groups. So my x-axis is the age group, So the age group here, and then I have the teens versus the tweens. So I'm just separating by group. And then within the teens, I have my different categories. And so here's where I've got to pay attention to the key. So as we look at the key here, we have the different categories being listed out. Okay, and so we have this telling us how to read the graph, right? And so for the teens, we can see how many had none. So that would be the bar here, how many had less than 2, how many had 2 to 4, and so on. So we have all of that distribution right there for the teens. And then right next to that, we have the distribution for the tweens. A couple of things to note then. As I look at my graph, so my x-axis was the two groups. My y-axis is in percentages. And the reason that I have to do percentages here, if we kind of go back to the example, so I have to do percentages as opposed to counts because I had two different sample sizes. There were 746 teens versus 560 tweens. And so in those instances, I can't compare counts directly because there was already more individuals in one group than the other. So I got to make sure to convert everything to percentages so everything's on an equal playing field. And so as we look at that then, now when we have everything set up and ready to go, we have the two groups all measured on the same scale, and we can do direct comparison. So we can see that in this case, tweens were much less likely to have 8 or more hours on a digital device than the teens were, whereas the tweens were more likely to have less than 2 hours of screen time compared to the teens. And so we can start to see those big differences, what's the most common for this versus most common for the other, what are the similarities, what are the differences, and we can analyze based on that. Now this side-by-side bar graph though, if I don't want to separate the two groups out, what I can do instead is basically create two bar graphs in one. And so another way of organizing the information is to put my variable on the x-axis. So we're looking at daily screen time. I have the categories, so none, less than 2, 2 to 4, and so on. So this time I'm breaking everything down by the category for the one single variable. And then from there, I'm looking directly at how did the teens versus the tweens compare for none? How did the teens and the tweens compare for less than 2, and so on. So now I'm putting the bars side by side, hence the name, where I'm doing both groups for each category directly related to one another. And again, we can see those big differences amongst the different groups. So who was more likely or less likely for any given category. And then the other thing just to note, making sure we have our percentages on the side. So again, not comparing counts, but percentages because of the different sample sizes. So when you create a side-by-side bar graph, you can use either method. So separate out the multiple groups and put the entire distribution for each side by side, compare and contrast the different aspects of it, or you can create the variable on that x-axis with all the different categories, and then by category, you directly relate each group to one another. And then we make our conclusions or we analyze our data based on the results of that. So 3 graphical displays, all of which you need to either know how to create, except for the pie chart, we're not going to worry about that. Otherwise, it's about interpreting and analyzing the information based on that graph. Last couple things here. So being careful with these graphical displays, we talked about being able to accurately reflect the information. So in pictographs like this, basically it's a bar graph where we use a picture as opposed to a bar. So if they're created correctly, it works the exact same way as a normal bar graph would, but we have to be careful with how data gets represented in these graphical displays. For instance, if I'm looking at these average female heights per country, and we're looking at how the different comparisons are here, we notice that the Latvian women, so their icon for their particular bar versus the Indian women's icon are drastically different in size. This makes it look like the Latvian women are like 5 times bigger than the Indian women. And if we look at that though and analyze where the scale is, we notice that the Indian women had a height of about 5 feet, Latvian women had a height of about 5'5". So it's only a 5-inch difference, but it makes it look like they're drastically different in terms of heights because of the way the pictograph is set up. So this would be an example of a misleading graph. It makes us draw incorrect conclusions based on what we see in the picture as opposed to what the numbers actually tell us. So we have to be really careful with how we display our data so that it accurately reflects what we're looking for. The last thing here, dealing with the scales. So one of the things I highlighted when we talked about our bar graphs was the scales. So making sure that y-axis starts at 0. So as I look at this graph, my first graph starts at 0, my second graph starts at 10. They go by 10 percentage points on the scale for the y-axis, which is fine. But when I look at the two graphs and we think about how we would interpret or how we would talk about the different groups here, what you have to be careful with is in this right graph, my none category and my PC category look drastically different. The none looks like it's about 4 times bigger than the PC. And that's because we did not start that Y scale at 0, and so it misrepresents the differences amongst the two groups. When I look at what it should look like, starting at 0 with even increments, we see that the none isn't even twice as big as the PC. So the way we display it can alter what our perception and what the conclusions that we draw would be, and so we have to be really careful of that misleading information. So starting at 0 for the Y scale, making sure everything is matched up correctly, and then making sure that we have like equal width for bars and not misrepresenting things as we graph. So with that, you should be able to complete the homework for tonight. So these are the problems you need to try out. It's going to walk you through the different bar graphs, the pie charts. It's going to walk you through questions on the side-by-side bar graphs and stuff. You might have to create a couple of graphical displays, analyze a couple graphical displays, and so just try to do what you can here. And then answer key for this will be up tomorrow as we start into our next section, which will be dealing with the quantitative data.